Hi everybody, welcome back to eLearning. Today we're going to continue our lessons on inverse trig, and we're going to start with a warm-up for today. So we've got 3 problems on evaluating, 3 problems on solving from 0 to 2 pi, and then 3 problems on solving for x. You can go ahead and pause this video right now to take as much time as you need to complete problems 1 through 9, and then I will go over them momentarily. So give you a couple seconds to pause. Okay, hopefully you have restarted the video by now, and I'm going to go through the answers. Again, take time to pause and then come back when you're done completing these, if needed. Scroll down. Okay, so problems 1 through 6 should look quite familiar to everything that we've been going over the past few days. 1 through 3, there's no equal sign, so this is implying that you are simplifying or evaluating, which we have to think about principal intervals. In order for a function to work, it has to be 1-to-1. Sine, cosine, tangent, these are not 1-to-1 functions, thus we've restricted their domains in order to be 1-to-1. The principal interval for sine, just going over these graphs again, going from negative pi over 2 to positive pi over 2 covers all the positive and negative ratios. Thus, the only answer we would use for problem 1 is negative pi over 6. So that angle, if I zoom in, would be about right here. That angle has a sine of negative 1/2. Cosine. Cosine's different. That's the restricted graph for cosine inverse. Thus, we would use values from 0 to pi. So 2 pi over 3, which would be about right there, maybe right here, has a cosine of negative 1/2. And then tangents, building a graph of tangents. So like sine, we would go from negative pi over 2 to positive pi over 2. So I would use negative pi over 4 for my answer for problem 3. Again, inverse trig is thinking, okay, what angle has this given ratio? Problems 4 through 5, now that we're solving, principal intervals out the window. We have to come up with all the answers within the given domain. So my only answers have to be from anywhere from 0 to 2 pi. So when I'm solving, you can see that I created graphs to show where these angles are located. All 3 of these problems, those ratios are things that I know from the unit circle, as you can see from above. Thus, I didn't need a calculator to come up with my answers, but I did have to think about where the correct, what quadrant my angle would be in. And now we get to 7 through 9. These problems look just about the same because the equations are the same. However, now I've asked you to solve for all values of x. If I look at problem 4 and 7, and I think about how many angles have a sine of negative 1/2, there's an infinite amount of angles that have a sine of negative 1/2. Between 0 and 2 pi, there are only 2 answers, but now I'm asking you to tell me what every single answer is. I don't have time to write down every answer because I would be doing that forever, but I do know that anything that's coterminal with 7 pi over 6 will have a sine of negative 1/2. So if I keep adding 2 pi to this angle, I'm going to get all the answers. So I'm going to use 2 pi k, where k is an element of the integer set. K is any integer, so I could add 1 times 2 pi, 2 times 2 pi, 3 times 2 pi, etc., etc., etc. And I would do that for this answer as well. And now I realize, actually, when I was showing on the graph, that was for the 11 pi over 6. And then if I added, it's a different color, 2 pi to 7 pi over 6, that would get me something coterminal there. So these two equations are representing all the angles that have a sine of -1/2. And likewise, I would do the same thing for 8 and 9. So I'm going to go ahead and add plus 2 pi k plus 2 pi k, where k is an element of the integer set. Now, you might notice that I only wrote down one angle for tangent. In theory, I can write down both of them. Oops. And for each of these, I can add 2 pi k. And this will represent all the angles that have a tangent of -1/2 because I found everything that's coterminal to those respective angles, given that k is an element of the integer set. However, if I look at the graphs above that I showed for 4, 5, and 6, 4 and 5, sine and cosine values, we can't easily get from one of the angles that's an answer to the other angle because they're in quadrants that are adjacent to each other. But problem 6, if you look at my graph, 3 pi over 4 and 5 pi over 4 are exactly pi away from each other. So I don't need these two equations. I can actually just add pi k, where k is an element of the integer set, specifically for tangent, because all tangent values have a period of pi, thus they start repeating every pi distance. So it wouldn't be wrong to write down what's in green, but it's more efficient to write down what's in purple. So this is our new objective of the day, really, is we've solved for angles on a given interval, which is in 4, 5, and 6, but now we're able to also solve for all the given values, which is what I just went over in 7 through 9. I'm now going to give you some time. Again, you can pause the video to go over problems 1 through 3. This is our practice of the day. So we've gone over solving, and now you have to pay special attention to what's the interval. Am I solving from 0 to 2 pi? Am I solving from 0 to 4 pi? Or am I solving for all values of theta? So go ahead and pause your video, and then I will go over problems 1 through 3 momentarily. Let's give you some time to pause. So now I think you've paused, and now you're coming back to check your answers. I always think that pictures are very helpful. I like to draw where my angles are, figure out what quadrant I need to be in. That's something that's very useful for me. In problem 1, something to remember, that's a squared value, so when I take the square root of each side, I do have to account for the positive and negative. So I wrote down all angles, or when I'm solving, that have a cosine of root 2 over 2, both positive and negative, and I'm only looking for angles between 0 and 2 pi. So we've got pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. Problem 2, now I'm solving for all values. So I am going to show a quick picture here. So I know my reference angle is going to be pi over 6, but I'm thinking about negative sine, so that's going to be in quadrants 3 and 4. So I found my answers to be 4 pi over 3 and 5 pi over 3, and then I'm finding everything coterminal to them. So I'm adding 2 pi k, where k is an element of the integer set. Then I go on to tangent. It's positive, so I can work with something in quadrant 1. I know my reference angle is pi over 3, so I found my first angle, and because the period of tangent is pi, I know the other answer is going to be a distance of pi away. Thus, I add pi k to get to quadrant 3, and then I can just add pi again and again and again. Go ahead and now take some time. These were 1 through 3, because those are all ratios that we're very familiar with from the unit circle. These 3 problems do not require a calculator. Problems 4, 5, and 6 do. So now you can take some time, go ahead and pause your video, get out your calculators, and go ahead and solve these 3 equations. When you're done, come back to the video. Alright, so I think you've paused and now you're coming back to check your answers. Again, anytime you can talk through how you're solving, if you can explain your reasoning, that's really telling you I truly understand what I'm doing. And in problem 6, that is going to test our understanding. Not that I've written down the answer, but let's go back down. Here I would have cosine of theta equals 5 over 2. Well, if I'm thinking about a cosine graph, I know that the max output for cosine is 1. Thus, could I ever have a ratio of pi of halves? No, so this problem has no solution, which is why you got an error on your calculator if you attempted to solve that one with your calculators. And here's all the work for problems 4 and 5. There was a lot of thought going into problem 4. Your calculator will spit out the answer within the principal interval. So what angle has a sine of negative 0.7? That would be negative 0.775. In purple, that's our angle. Well, I can use that and I can add 2 pi to that. So that's highlighted right here. That's acceptable because all my answers are coterminal to negative 0.775. But to find another angle, because I know that sine is also negative in quadrant 3, and I know that it would have the same reference angle as negative 7.55. So if I reason through this, I know that the angle is going to be more than pi, and how much more than would be the same as the reference angle. So I did some work here. Pi plus 0.775 would equal 3.917. And then I would want anything that's coterminal to that. So here are my 2 equations that I need to represent all answers that have a sine of negative 0.7. Problem 5, is it okay to have a tangent that's more than 1? Yes, because if I draw the graph, the range is all reals for tangent, so I can have a tangent of 1.2. I go ahead and use my calculator to solve this. I get an angle of 0.876 that would have a tangent of 1.2. And then I just have to add pi to get the angle that has the same reference in quadrant 3. And then I would just keep adding pi to represent all the angles that have a tangent of 1.2. Thank you very much for watching this video and practicing your work on solving equations to find all angles within a given interval, or to find all values that have a sine, tangent, or cosine of a given value. Thank you very much.